Okay? And the reason we're going over properties of compounds is it's going to have to do with the lab that we will be doing on Wednesday. Okay? So what we're going to learn today will help us to identify several unknown compounds. Okay? So on Wednesday, we'll be in the lab, and there will be compounds A through J, in little beakers on the front desk. Okay? You will have to use their physical properties in order to identify them. Okay? What we're going to go over today are physical properties and how those could be used to identify unknown substances, so that on Wednesday you're able to do it. All right? The other thing we're going to go over today is lab report format and expectations, so that you will also have some idea what's expected in that area. And then tomorrow we will start doing our pre-lab stuff after our quiz on naming that will be posted at the end of the day. I promise it'll actually happen this time, it won't be 6 o'clock. Okay? So that's kind of the plan going forward. Okay, so we've got stuff we got to learn today, pre-lab stuff tomorrow. We'll have basically most of the period to work on, the pre-lab part of the lab report. Okay, Wednesday we'll do the lab, and Thursday we'll probably be looking at properties of water and things like that, solubility and things of that nature, and going forward. All right, so that's kind of the plan for the week. Okay, so this lesson here, okay, our key points: learn the properties of compounds. That would be acids, bases, ionic compounds, molecular compounds, etc. Okay, and understand how those properties can be used to identify a compound, which will be useful when you're designing your lab. Okay, so all matter has different kinds of properties. There are physical properties. Those are things that are readily observable about a material. I only require that material in order to see these things. Okay? Chemical properties are basically how reactive is this material? What kinds of things will it react with? Okay? In order to determine chemical properties, I have to react it with something else, okay, in order to see those. So what we're going to be talking about today are basically just physical properties. Okay? The things that we can tell just by making simple observations of a material. Okay? So some of those could be color. Okay? Color is a physical property. Density is a physical property. Solubility, how well it dissolves in water, is a physical property. The nature of it, if it's crystalline or metallic or non-metallic, okay? Things like that. Melting point, boiling points, right? All of those things are physical properties. Okay? Everybody with me so far? Right? So we're going to learn how those could be used to help us identify various unknown materials. All right, so if we're talking about ionic compounds, okay, when we first learned about ionic compounds, we said they happen when a metal and a non-metal combine to form a compound. The electrons are traded, okay, and as a result, these compounds can have charged parts, negatively charged nonmetals and positively charged metals. Okay? When we put them in solution, that is dissolved in water, that solution will conduct electricity because of those ions, the negatively charged nonmetals and positively charged metals that would be floating around in the solution. Okay? Now, other things that we can tell, or can help us to tell whether something is ionic, is that all ionic compounds are crystalline solids, okay? Or salts at room temperature. All ionic compounds are crystalline solids at room temperature. Does that mean all crystalline solids are ionic compounds? No, it doesn't. Okay? Most of them are, but there are exceptions. Okay? A diamond is not an ionic compound, but it is a crystalline solid at room temperature. Okay? Sugar is not an ionic compound, but it is a crystalline solid at room temperature. Okay? So there are some exceptions. So if I'm looking at a bunch of unknown compounds, and 9 out of 10 of them are crystalline solids, okay? It's a good chance that probably 8 of those are ionic compounds. Agreed? Okay? If all ionic compounds are crystalline solids at room temperature, okay, it's a pretty good chance that most of the ones I'd be looking at would be ionic. All right? I would just have to run one more test to confirm, and that's what we'll talk about today. Okay? Ionic compounds will conduct electricity when they are in solution. That is your single most important defining characteristic of an ionic compound. Sorry guys, good night. Okay, so the test that I would run, okay, to confirm whether a crystalline solid was in fact an ionic compound would be to put that crystalline solid in water, dissolve it, and then test the conductivity of that solution. Right? We have little conductivity testers that we use in the lab. Okay? They just have 2 electrodes and a button. Okay? You put them in, you press the button, and it tells you the conductivity on a scale of 1 to 10. I'll show you how they work tomorrow because you will be using them in the lab on Wednesday. Okay? But that test will 100% of the time tell you this one's ionic, that one's not. So if I had salt and sugar side by side, okay, that is how I would tell them apart. Okay? Because just looking at them, salt and sugar don't look a whole lot different. Okay? They both have fine, white, clearish crystals. Okay? They don't really have a smell, right? So I wouldn't be able to smell them. We never taste unknown compounds, okay? Because that'd be bad. I mean, salt or sugar isn't going to hurt you, but hydrogen chloride is also a white crystalline solid, and that would eat your tongue away, right? So, we wouldn't want to just go, oh, and that one's the salt, because it might not be salt, it might be something else, okay? So we wouldn't want to do that. Plus COVID, gross. We don't want to taste things, okay? So the best test would be to test the conductivity of it. That will tell me, okay? If it's between like 7 and 10, it's ionic. If it's 4 or less, it's molecular, okay? Molecular compounds will not conduct electricity. So if I put the 2, one of them being salt, one of them being sugar, the sugar will have very low conductivity, probably somewhere around 2, okay, maybe even lower. Okay. Everybody kind of following me on that?
4 or less is molecular?
Anything 4 or lower would be molecular, yeah. Okay. So this diagram here on the right is showing us why those solutions conduct electricity. That's what we were talking about a minute ago. When I put salt into water, a big chunk of salt, okay, it very quickly starts breaking up, dissolving, okay, and turning into negatively charged chlorine ions, positively charged sodium ions, and because there's this difference in charge, a current can flow through from charged particle to charged particle, okay, allowing that solution to conduct electricity, whereas if I did that with water, distilled water, or alcohol, or a solution of sugar in distilled water, I would get nothing because there would be no charged particles floating around to carry the current. Okay, everybody all right with that? Okay, so lots of ionic compounds will produce solutions that are brightly colored. So this will be really important because this is one of those super easy physical properties that you can use to help you identify something, is just to look at its color. Okay, so if I have a blue crystalline solid, it probably contains copper. And by probably I mean there's a 90 to 95% chance that it contains copper. There are very few other ionic compounds that would be bright blue in color. Okay, so if you've got something that's blue in color as a solid, okay, and when you put it in a solution, put it in water, the solution turns blue, you're looking at something containing copper. Okay, so copper solutions are always blue. Okay, nickel containing compounds are always green. Okay, there are a few other compounds that can be green, but they're very pale green. Nickel compounds tend to be quite dark, emerald kind of green. Okay, and then cobalt containing compounds will be anywhere from orange to pink to red. Okay, so cobalt containing compounds will generally be reddish in color. Okay, usually when they first come out of the container, they're quite a deep, almost blood red. Okay, and then as they oxidize with the air, they tend to turn kind of an orangish, faded pink color. Okay, but they're generally going to be reddish. Right. So, does that help you identify 3 unknowns out of your, what are there, 12 tomorrow? Yeah, for sure. Okay, I got a blue crystalline solid. It's probably a compound containing copper. Okay, and so on and so on. Now, you're probably thinking, Coder, I got to guess what these compounds are. So they contain copper. Big deal. It could be copper chloride, copper sulfate, copper sulfide. I don't know. Well, the answer is that the possible identities will also be on the lab. Basically, it's just matching Okay, you've got something that's a blue crystalline solid, and one of your unknowns is known to be copper sulfate. Oh, great. Okay, I can match that up. Okay, and so on. So everyone kind of follow me there? I'm not actually going to say, okay, figure out 1 in a million chance. What is that one? That's not what we're doing. Okay, the possible identities will be there, and what you'll be asked to do is say A is water, B is hydrochloric acid, C is sodium hydroxide, and so on. Okay. All right. Everybody okay with this so far? No.
So as long as we know how to figure out the compounds.
Yes. Yes, absolutely. Okay. And I mean, there's only a couple that might be a bit tough, and you just save them for last when it's okay. This one must be that, and this one must be that after you've kind of got the obvious ones, right? I mean, one of your unknowns is water. Okay. Now, water's got some pretty well-known characteristics. Agreed? Like, if you got 2 clear liquids, you're gonna have 2 clear liquids. Okay, as unknowns, right? You're gonna basically a 50-50 chance if you just guessed, but one of the liquids will have something that will obviously tell you it's not water. Okay, and the other will be very obviously water. All right, stuff like that. So it'll be pretty straightforward. Okay, if we're talking about molecular compounds, okay, the difference between molecular compounds and ionic compounds, obviously, first off, ionic compounds are crystalline solids. Molecular compounds are not always, and generally not, crystalline solids, because you get crystalline structures typically, okay, because of the arrangement of the particles. And if you've got positive, negative, it's very orderly. Okay? And so when they're in a solid form, they tend to form very orderly shapes like crystals. Right? Molecular compounds don't do that because they don't have that kind of arrangement. Okay? They also tend to have lower melting points and lower boiling points. So they tend to be more often liquids or soft solids, okay, or even gases at room temperature. Right? Butter would be an example. Okay? At room temperature, butter is a fairly soft solid. It's definitely not crystalline. Agree there? Okay? Water is a molecular compound, liquid at room temperature. Alcohol is a molecular compound, it's a liquid at room temperature. Carbon dioxide, okay, is a gas at room temperature, molecular compound. Right? Even things that are molecular and crystalline solids, okay, still tend to have like pretty low melting and boiling points. Like sugar, for example, you can melt it in a pan. Okay? If you do that, make sure you keep a careful watch on it because it also burns very easily and it's hard to get off the pan if you burn it. Okay? So yeah, they tend to be have low melting and low boiling points. Okay? And they also tend to be a bit less soluble. Okay? For example, candle wax is a molecular compound that is a soft solid at room temperature, but doesn't dissolve in water. Okay? Oil doesn't dissolve in water, it's a molecular compound. Okay? Butter, same thing, doesn't dissolve in water. Okay? All fats kind of things like lard, shortening, and stuff like that, they're all molecular compounds, they don't dissolve in water. Are there some molecular compounds that do? Yes, sugar dissolves in water, we'll be able to sweeten drinks without it. Okay? Alcohol dissolves in water, okay, very easily. Okay? Molecular compound, but they tend to be less soluble than ionic compounds do. Okay, they're also not going to conduct electricity. Okay, so that's going to be a big one. Okay, molecular compounds do not conduct electricity in solution. Okay, so they tend to not be as soluble as ionic compounds, and the solutions they form do not conduct electricity. So we just want to look at this from a process of elimination kind of standpoint. Okay? If I've got something that's a liquid as one of my unknowns, I know it's not an ionic compound. Okay, so I know right away anything on my list of unknowns that's ionic, that's not it. Okay, everyone kind of follow me there? Right? If it's a solid but it's not crystalline, I can also cross any ionic compounds off the list. Okay, and I can start looking at just my molecular compounds. Okay, molecular compounds do not have typically bright colors either, right? So if you make a solution with them, it's going to tend to be clear or maybe cloudy, okay? But it's not going to have a bright blue color or a bright red color or a bright green color, okay? Molecular compounds tend to be clear. Okay, questions so far on that? Now, Some of the unknown compounds will have very low pH. Okay? They have a very low pH, then they're an acid. Okay? Anything technically with a pH of less than 7 is an acid. Okay? So things like citric acid. So if you have like a lemon or an orange or something like that, they contain citric acid, that has a pH of about 4. Okay? Your stomach acid has a pH of about 2. Okay? One of the ones that you're going to have as an unknown is going to have a pH of 1. Okay? I mixed it the other day. It's nice and strong. Okay? It's going to turn the pH paper bright red. Typically, your strong acids are going to be ionic compounds. Okay? Most molecular compounds are near the neutral area. They could be slightly basic and slightly acidic, but they're not going to be strongly acidic. Okay? Citric acid is an example. It's actually a molecular compound. Okay? It's not a strong acid. pH of 4. Rain can have a pH of 4. Okay? So it's not something that's super acidic. Okay, so strong acids are going to be ionic compounds, and they're going to contain hydrogen as the metal. Okay, so hydrochloric acid is a very common, strong ionic acid. This is actually stomach acid. Okay, hydrogen chloride is stomach acid. Okay, when it goes into solution, it becomes H plus and Cl minus. By definition, any ionic compound that will donate H plus to the solution is an acid. Okay? The more H plus it will donate, the more acidic or the stronger the acid will be. Okay? So which would be stronger? HCl or H2S? Which one will give off more H plus when it goes into solution? H2S. Okay? Anytime an acid has lots of hydrogen to give away to the solution, when it goes into solution, it will be more acidic. Okay? This stuff, super acidic. Okay? You don't even want to get the fumes from this on your skin. Okay? Or they will cause severe blistering chemical burns. Okay? Hydrogen chloride, okay, it's a weaker acid than those two, but it's still a strong enough acid. Okay, if you were to inhale it, it would knock you flat on your back with a nose. Okay, so they're strong acids. They donate a lot of hydrogen plus to the solution. Okay, so any ionic compound with H plus as the metal is going to be an acid. Okay, so that is something you're going to want to look for. Right? If in the lab on Wednesday you're doing a pH test and you get something that's a strong acid, turns the pH paper bright red, then what you want to be looking for is any compound that's got H as its first elements, okay, and it's an ionic compound. Okay? The reason I say it's an ionic compound is because I don't want you to say, oh, that's my strong acid. Because what's the pH of water? 7. It's neutral, right? Water's neutral, right? So I don't want you to think that anything that has H plus or H, sorry, as its first thing is going to be an acid. It's not. It's got to be an ionic compound with H listed first. Okay. All right. So acids are ionic compounds. They share lots of their properties. So your strong acids are not only going to be crystalline solids, they're also going to conduct electricity. In fact, they're going to be your best conductors of electricity. When you stick the electrodes in the acid, it's going to be a conductivity of 10 for sure. Okay, they're highly conductive, right? And obviously highly acidic, so they have a very low pH. Okay. Now, the other thing it says on here is that acids taste sour. Good. You're never going to experience that. Taste tests are not part of the lab. Okay? Nobody is going to taste any of the solutions, right? I mixed the acid really strong. If you drink it, it will be the last thing you ever drink. Okay? It would be very, very bad. It'd be like, eating a spoonful of Drano. Okay? Sure, it'll clean you out, but it'll leave you hollow inside. Okay? And we don't want that. So, no taste tests. Okay? Nobody tastes anything. Okay, but do acids typically taste sour? Yeah, I mean, think of citric acid, right? If you bite into a lemon, right, it's sour, right? Vinegar is kind of sour, it's an acid, right? But we wouldn't want to try anything else. Okay? They also tend to have a vinegar-like odor. Okay? Most acids will have a vinegar-like odor. They'll have that kind of, you know how it almost feels like if you smell vinegar, it almost like curls the hairs in your nose. Okay? It's kind of like that. Most acids will have that same kind of effect. Now, should you be like actively like sniffing your unknowns? How do you generally see if something has a smell safely? Wafted, right? So you hold it about this far away from your face, and you just push the fumes towards you and gently inhale. Okay, you're not going okay like that. We don't want to do that. Okay, I mean sure you'll get the smell, but you might be flat on your back too. Okay, so we don't want to do that. Just waft it. If anything has a smell, it'll be obvious enough just by doing that. Okay. All right. Questions on acids? Now, bases, your strong bases are also going to be ionic compounds. Okay, and so a strong base could look like this. We actually talked about this one the other day. This is sodium hydroxide. Okay, it's the stuff that's in oven cleaner. Okay, it's in lye. Okay, the stuff that they put down like pit toilets and stuff like that to keep them from getting too smelly because it kills all the bacteria. Okay. So anything that, when it breaks up or goes into solution, will give off hydroxide ions is going to be a base. Okay? So bases always have OH or hydroxide ions in them. So sodium hydroxide would be a strong base. Okay? This stuff would also be a strong base. Which one would be stronger? First one or second one? Second one gives more OH. Okay, the more OH you can give, the more basic it's going to be, the stronger the base it's going to be. Okay, now would this be? Would that be a base? This one's tricky. It ends in OH, right? I just finished telling you that anything that ends in OH must be a base. As long as it's what kind of compound? Ionic. Is that an ionic compound? It is not. Okay, it starts with carbon, which is a non-metal. Okay, this is ethanol. Okay, that's alcohol. What's in booze? Okay, that's what that is. Okay, in hand sanitizer and other things. Okay, so that, not a base, not an ionic compound. With me there. So you got to look at it carefully. Don't just go, oh, that ends in OH, it must be that one. No, not always. Okay? If it's ionic and it ends in OH, then yes. Okay? If it's molecular ends in OH, not necessarily. All right. Basic solutions have a pH higher than 7, and when you put pH paper to them, they are going to turn bluish colors. The darker the blue, the stronger the base that they are going to be. All right. They're also, because they're ionic, they're going to conduct electricity. They, like acids, are going to be some of your best conductors because they most easily dissociate in water that is split into the positive and negative parts. Okay. Questions on that? Okay. All right. So what we're going to look at here next is just going to be the lab report stuff, and then we'll talk about the tests that we're going to be running, okay, in order to do that. So I'm going to give you about let's give it till 10 after 9. Okay, quick break here while I get this stuff set up for the next lesson. Okay, so 10 after 9, we'll start on that.